Unit 5, Form of 3, Day 5, Dividing Radicals. This is probably one of my favorite ones because you can always make things simpler. So whatever fraction rules we have, they work inside radicals. So for example, if I had, 2 over 6, I would reduce that to 1/3. Okay. The same works if 2 over 6 is in a radical. It simplifies to 1 over 3rd. And just like if you're multiplying, let's say we have 2/3 times 6/7. Okay, you know that the 3 and the 6 can cancel or reduce. The same thing if I had this. My 3 and my 6, that's a 7, sorry. My 3 and my 6 would cancel. Alright? So the rules you have of fractions are going to hold up here with square roots. Alright, so first of all, so we have square root of 3 over 6. Okay, 3 over 6 will simplify to 1 over 2. Okay, now here's the rule with division or fractions. Okay, this is the same thing. Okay, you need to break up your square root. Okay? Now you can never have a square root in the denominator. Okay? You always have to get rid of a square root when it's in the denominator. Okay, so let me rewrite this down here. Okay, and how we do that, so I cannot have a square root down here, and how we do that is we multiply it by itself. So if I want to get rid of the square root of 2, I'm going to multiply by the square root of 2. Now fractions are a lot like equations. If you do something to the denominator, you also need to do it to the numerator. Okay, so if I multiply the denominator by square root of 2, I also need to multiply the numerator by square root of 2. So the square root of 2 times the square root of 2 is 2, right? Because that's 4, right? And then we have 2 2's, factor 1 out. Okay? So whenever you take a square root times itself, it's just the number under the square root. So the square root of 6 times the square root of 6 is 6. Okay? All right, now up here on the numerator, square root of 1 times the square root of 2 is square root of 2. Okay? This is my answer. You can't simplify these because this 2 is under a square root and this one is not. So never simplify something when one is under the square root and one thing is not. All right, so here we have 5 over 2. You can always look, 5 over 2. Can I simplify 5 over 2? No. Okay. What about 2 over 15? Because both of these are inside the square root. No, I can't simplify those either. Okay. Now you cannot simplify 5 and 15 because the 5 is outside the square root and the 15 is inside. Okay. Now the rule again, one rule, is you cannot leave a square root in the denominator. So I need to get rid of the square root of 15. And how I'm going to do that is I'm going to multiply it by itself. When I do that, I also have to multiply the same thing by the numerator. Okay. Now we have a pair of 15's. So that's going to be 15. Okay, so 15 times 2 is 30. Okay. Now up in my numerator, okay, so I have 5 times 1, which is 5, and then 2 times 15, which is 30. Okay. Always double check. So I have a square root of 30. I break that down into 6 and 5. 5's prime. 6 is 2 and 3. There are no pairs, so 30 can stay in the square root. Okay. Now let's look at, so 30 is the only one in the square root, so it's going to stay, but let's take a look. We have 5 and 30. Will something go into both of those? Yes, a 5 will, so we need to simplify that. 5 will go into 5 one time. 5 will go into 30 6 times. So it's 1 square root of 30 over 6 is our answer. Okay, here we go. On this one, we're multiplying two fractions. They're both in the square root, so you can simplify or cancel. For example, look at 75 and 3. What will a number go into both of those? And it will. So let's go ahead and simplify. So 3 went into 3 one time. 3 will go into 75 25 times. Okay. All right, let's take a look at 16 and 4. Will something go into both of those? And 4 will. So 4 will go into 16 4 times. 4 will go into 4 one time. Okay. Now we're going to multiply. I'm going to go ahead and break up my square root. 16 times 4 is 4. And then 25 times 1 is 25. Now they're both under the square root. Okay. So I'm going to go ahead and split them up. So the square root of 4 is 2 times 2. So I have a pair of 2's. Okay, and then the square root of 25. And some of you guys will probably already know these as perfect squares, and you can skip this step. The square root of 25 is 5. Okay? Make sure you can't reduce it, and there's my answer. Last one, same type, okay, but we can't simplify on this one. 5 won't simplify with the 3, and the 2 won't simplify with the 7. So we're going to multiply like fractions. We're going to multiply straight across. So 5 times 2 is 10. Okay, and 7 times 3 is 21. Okay. Now, my rule is I cannot have the 21, so I'm going to multiply it by itself. Okay. So 21 times 21 is 21. Our square root of 21 times the square root of 21 is 21. Right, and then 10 times 21 is square root of 210. Okay. Now we need to make sure 210 doesn't have a perfect square in it, or it can't be simplified. So off to the side here, I'm going to go ahead and break 210 down. So that's 21 times 10. It ends in a 0, so I know 10 will go into it. 10 is 5 and 2. 21 is 7 and 3. Okay. They're all prime, and there's no repeats. So 210 is a simplified square root. Okay. See you guys in class.